I think I've recorded videos of me solving SQL and Python problems using HackerRank and StrataScratch. There's another platform called DataLemur. I discovered this on LinkedIn, and so all these different platforms I just named, they're similar to LeetCode, but they're specifically for data scientists or data analysts. So here's a quick summary about the guy who created the platform. He wrote a book called Ace the Data Science Interview, and this platform is, it goes with the book. And then he looks like he worked at Facebook and Google. And so let's get into these problems. He used to just have SQL, but now they have stats and ML. I'm going to filter to SQL because that's all I need to do right now. And on the right hand side, you see my progress. You can see I mostly dabbled in easy and then a few medium, but didn't touch any of the hard ones. I use SQL and Python mostly at work, but I want to level up my SQL skills. What I have is very beginner and it's proficient for what I need to do, but I want to also explore other maybe more efficient ways to do queries. And also just recently I started using StoreProc, and that's kind of what motivated me to come back and kind of go through SQL again. So you can see these check marks show that I've completed these, but I'm going to redo the easy ones, record these, and explain my thought processes as I solve them. So let's get into the prompt. The prompt is called Page with No Likes, and the prompt is, Kitty, do not bite my cord. Assume you're given two tables containing data about Facebook pages and their respective likes, as in like a Facebook page. Write a query to return the IDs of the Facebook pages that have 0 likes. The output should be sorted in ascending order based on the page IDs. Okay, now I'm going to take notes on what I need to do. So they're asking me to return page ID in ascending order, but not just every or any page ID. It has to be page ID that have no likes, 0 likes. And they said there are 2 tables. Okay, that indicates to me I need to probably join the 2 tables. There might be some information in one table and then a second set of information on the second table, and the only way to see the full picture is to actually join the 2 tables. Below the prompt, they have a schema right here, and then they have a sample of what the row contents will look like. So for this first table called pages, there are 2 columns. One's page ID, the other is page name. And do you see it also has a type to tell you what type of data type it is. So for page ID, it's integers, so just numbers, and page name is varchar, which is like string, so it can be alphanumeric. And then this is what the rows could look like. They only gave us 3. It could be 10, 15, who knows. And then there's another table called page likes, and there are 3 columns: user ID, page ID, and liked date. So this second table gives you a timestamp of when a particular page was liked. And something else I see is there's a page ID in this table and a page ID in this table. So that means these are the 2, that's kind of the overlap between the 2 tables. So if you had a Venn diagram, you have table A, which will be pages, and table B, which is page likes. And when you look at the 2 tables, what's in the middle? It's the column called page ID. So if I'm going to join leading on table A, which is pages, then this page ID of pages is going to be the main key, and the page ID of the second table is going to be called foreign key. So let's look at the tables. So they give us a code just to start off. Select everything from pages. So we'll run the code. As we see on the left hand side, they only gave us 3 rows. Now if I do this, they might give me more. Okay, they gave me 5 rows. So they've got these. Now I'll look at page likes, run code. Okay, if you hear noise, that's my cat in the back. Okay. I think 20045 might be one of the tables no. 3111 was on the other table. 2001 was 20045. I don't remember. Let me look at pages. This scrolling is so annoying. $201 was here. Okay, 2071 is something that I saw in this table but not the other table. So I'm guessing this is, yeah. I'm just gonna make a mental note. This, and I think this. 31111 was in the other table. Okay, at least 20701 is going to be a table that I expect as a result for that does not have likes. 20701. So I'm just kind of making this assumption just based on quickly looking at the two tables. We'll see if it's confirmed when I code the problem. Also, down here, oh sweet, actually this confirms for me. Down here they have something called example output. So they only have one column, and right now it's just one row. But again, it could be 5 rows, 10 rows, we don't know. Because there's some things we just don't see. This is just a sample. So we know that they only expect one column called page ID. And again, they said it in the prompt too. They only want page IDs sorted in ascending order. Okay, well, I think my cat is building a sandcastle. Okay, so the reason I do this is so that when I go to code, I'm expecting that to be my solution. It's kind of like doing mental math and then going about solving the math and then seeing if it lines up with what you expected. So that's what I just did there. Now let's get into coding. Select. Let's not do everything. Let's do page ID. From pages. I'm going to give an alias. Why? Because there are two tables. So if I had to call columns from two different sets of tables, how do you know which column comes from what table, right? Because page ID is a shared column name between both tables. So I'm going to do this from P pages. I guess I'll keep this uniform, update or uppercase that. Select this from here, where page ID, p.pageid is, I'm going to use the not in function. The reason I'm using not in is because the second table is saying page likes. I'm assuming they're only going to include page IDs that have been liked because they have timestamps to associate when a page was liked. Now, if a page was never showed up on this second table but showed up on the first table, then that means the table that was on the first table but not on the second table, or the page that was on the first table but not on the second table, is most likely going to be a table that has 0 likes. And we, just by quickly looking at it, expect page ID 20701 to be on there, which happens to be called Tips for Data Analysts. That's the page name. So now within the function, we're going to say select from where. So I'm going to go ahead and do that. Now select what? PL from page ID. And from what page? Page likes. So PL. The reason I knew ahead of time was mentally I knew I wanted to give an alias of PL. Typically with aliases, I just pick the first 2 letters, like first letter of the words. Well, page likes is 2 words, and P is the first letter of page, and L is the first letter of the second word. Yeah, anyways. I think that's a standard practice, is you just kind of like do the acronym of the word. You could do like X, Y, Z and be super vague, or if you want, it's best to just give it a quick acronym based on the name. Where PL page ID is not null. And then we'll end this one with a semicolon. This means it's the end of the SQL query. So we'll run. Okay, there we go. We have two pages. One's 20701, which checks, like confirms my assumption when I first looked at. Then there's another table called 32728. So as you can see, example output, it only gives 1 row, but my output gave multiple rows. Now we're going to submit and see how they take it. Sweet, congrats. All right.